Today we are going to master the command line interface from zero to hero part 2. In the first part we covered the basics of the command line interface and a little bit of history. In this video we will cover pipes, redirections, creating a small script to make it executable so you can create your own programs, and finally also about environment variables and also a little bit more. With this you should have all you need to master the command line interface. Let's get into it. First, let's talk about file permissions. Here we have an empty Ubuntu system. If we list the files inside, we see that there are no files in. Let's create first one file. We use the command touch, which is a command that also allows us to change the timestamps on files and many other things, but for now it's very useful just to create an empty file. Test.txt, and now if we list the contents of the folder, we can see that the file is there, test.txt. So let's analyze a little bit this line here, what all this means. When we get something like this, basically the first element on this table is the name of the file. Then the next one is the modification or creation time of that file. Next, we have the size in bytes. Next, we have the group and user, number of hard links, and finally this part here, which are the permissions, which is what we are going to focus right now. Permissions are divided in 3 columns. Each of them contains 4 elements. R for read, W for write, X for execute, and the hyphen means no permissions at all. As we said, these columns are divided basically in 3 elements. The first column is for the user. So in this case, the user has read and write permissions. Then the group has read permissions, and then everybody else have no permissions at all. And this is showing you that file actually who can have access to this file and what kind of access that file provides for different users. Finally, we have here the file type. If we have a dash like this, it means it is a regular file. If it's a D, then it is a directory, and if it's an L, it's a link. With this knowledge here, we can understand now that this text file has the permissions for read for everyone. Then it has the permissions for read and write for the group, and the permissions to read and write for the user. Here, this is the user and this is the group. In this case, you can see Zuko is my user, and because by default is created just one user, it creates a group with the same name. Yours is going to be different. Now let's say that we want to change these permissions. For that, we use a command chmod. With this one, we can easily assign the permission that we want depending on which of these 3 columns, these 3 cases we want in case of the user, group, or others. So for example, in this file test, I want to change the user. I want to be, for example, read, but that's all. I don't want it to be write. Or for example, let's say actually the user is going to be write the same, then the group is going to be only read, and for everybody else, other is going to be nothing. And this is going for the file test.txt. Now, if we list again, we can see that now the permissions change. For other, there's nothing, and then for the group is only read, and for the user is read write. Let's roll back for a little bit and go back to the previous situation. There is another way of doing this, which is chmod, and for example, here we can say 6 and then 4 and 0, and then test.txt, and when we list, we see exactly the same result as before. This 640 is the octal notation, and this is something that could be a little bit confusing now, and at the end of the video I'm going to explain how that works. This is the way I use most often because I already got used to it, but at the beginning I think it's easier if we go back to the previous notation, which is just using symbols, which is more intuitive. We roll back a little bit here to how it was at the beginning, and now we want to add execution permissions just for the user. To do that, we don't need to go and repeat ourselves and say like user equal, in this case, RWX. We can just say U plus X and then the name of the file. If we do that, notice that now when we list, here we have an X, and any other permission that existed before is preserved. What it means to be execution? Well, execution is in Windows, for example, when you have a file, if you have something like test, exe, it becomes an executable. But in case of Linux, you don't really need that. The extension is not really that important. What is important is the permission here. And execution means that that file will become a program. It's not that it becomes, it has execution permission, meaning that if it is, for example, a program or a script, then you can execute it as executing any other program. So in this case, even if test.txt has execution permission, because inside is empty and it's not really a program, even if we try to execute it, it's going to fail. We're going to talk more about this later when we learn how to create bash scripts. One last thing here is users. There is a user called root. Well, this user is basically the all-powerful user. It can delete everything, access everything. It can change the operating system. It has permissions for absolutely everything. There is nothing that can stop the root user. Usually the root user is identified like here with the number sign, but this is just a convention. It doesn't have to. So in order to know who you are, for example here, who am I, this command is telling me that now I'm the user root. If I execute this command again on my user, it's going to tell me that my user is Zuko. So you cannot really trust on what is here. This is something that can be configured on an environment variable. So as I said before, the root user is all powerful. I'm going to give you an example now. So here in my user, I type the command pwd print working directory. It's telling me I'm in home Zuko. This is my home folder. If I list the content, I can see that there is this folder here called for root only. So it means that the root user, the administrator of the computer, was a little bit mean and created this folder with only permissions for itself. So there is no permissions for others and no permissions for the group. In case of a directory, the X is not executable. We cannot execute a folder, but what it does is access permission. So it tells you if you can access or not that folder. So as the user Zuko that I'm here, I try to change into that folder. It's telling me permission, then I cannot access that folder. Now we are going to talk about redirections. Redirections deal with input and output. Programs receive an input and produce an output. Input and output is distributed across 3 streams, standard streams, which are called. These streams are the standard input, the standard output, and the standard error. And they are internally called std in for input, std out for output, and std er for error. So for example, in this scenario, we have a process. A process, let's say it's a program, any kind of program, where the standard input is the keyboard. This is the default behavior. All of these can be changed, of course, but this is the default behavior you have. Then when it receives an input from the keyboard, then the standard output is going to go to the screen. You're going to see it there. And if the program produces an error, that error is going to also be displayed on the screen. So the standard error and standard output both go to the screen. So now, how to identify these streams? What we use for that is which is called a file descriptor, which is a number that is assigned for each of these streams of data. So for the standard input, the number is 0. For the standard output is 1. And for the standard error is 2. We're going to see later how these numbers play a very important role in redirections, basically redirecting data from one point to another. Here we are back to our home folder, which in this case is again empty, and I want to list the files that exist in the root folder. Basically, is going to be the starting point of our file system. So ls-l and then /. You can see here we have links, we have directories, it's a lot of stuff, but the only thing we care about this is the output. We have quite an interesting output that we can work with. So how redirections work? So in this case, the program ls-l, and then we pass the parameter of the / indicating where to actually list the files from, is going to dump all the data into the standard output that, as we saw, is the screen. Now, I want to redirect all this output to a file. So I don't want it to be shown on the screen, I want it to a file because maybe later I need to process that information in the file for whatever means. So let's go back here. Let's execute the same command, and actually to go back and forward the commands that we typed already, you can use the up and down arrow in the keyboard. So in this case, we're going to use this symbol here, which is Maybe you know it from high school in mathematics, like more than, and there is another one, less than. And this is used also in programming, many programming languages, to actually specify precisely that, the mathematical meaning, something that is more than something else. But in this case, this arrow, look at it as basically like an arrow, something that says whatever is here on the left is executed, and the output is going to end up in the file I'm going to indicate on the right. So let's say ls out. This is going to be the output of the ls command, txt. And you can see that there is no output on the screen. But if we now list the files inside, we see that ls out is there, and it actually has some content. Another utility we are going to learn how to use is cat from concatenate. What it does is basically takes the content of this file, which in this case now contains the output of LSL, and it's going to dump it into the screen. So here we have, that's the content of the file in there. Another thing you can do is use Nano, which is a normal text editor. In this way you can browse the file and just edit it. But we are going to use cat more often because it's easier to see the content of small files. They just show that on the screen and it's easy to see the content of it. Now let's change the parameters for ls, and instead of -l, we're going to replace it by -1. And again, we're going to list the root of the file system. If we do that, what is going to happen is that it's just going to list the name of each element, each file or directory that is there, one by one after the other. It's not going to give us any more detailed information. So now with this in hand, if I now repeat this and say ls out, it's going to behave exactly the same. But in this case, if I cut the contents of this, we can see that the previous output doesn't exist anymore. What if we don't want to do that? What if we want to just append this after what we already had before? So in this case, let's repeat the same command we had before. And here we have the contents of the previous command as we did at the beginning. Then we execute ls-1. And in this case, instead of one of these more than symbol, one redirection, we put two of them. This is going to append whatever is the output of this command into the file lsout.txt. If we do that, and now if we cut the content of lsout, we can see that we go up. Here's where we execute the command. This is the output. This is the first execution, the first time we executed ls. And then after that, as you can see, it's appending that other output after that. So this is a way for you to append the data into the file instead of doing one redirection, which is going to basically remove everything that is there. It's going to be replaced by the new output. Now, what happens with the error messages? As we saw before, they are redirected to the screen as well, but there is a completely different stream of data. So, for example, if I just type ls missing file, it's going to give me an error because there is no such a file or directory called missing file. So this was an error message. If I do the same, ls missing file, and I redirect the output of this to ls out, for example, we'll still see the message on the screen, meaning that this was not redirected to ls out. If I cut the content of ls out, it's empty. So how can we redirect the error message into a file? Well, remember about the file descriptors that we talked before, the numbers that who represent them. So in this case, we do the same. This is going to be ls missing file. But instead of just leaving it like this, which is the default, is going to be the standard output, we put a 2 in front of it. This 2 is the file descriptor of the error, the std error, the error stream. So if we now do this, we see that the message now doesn't appear because it ended up in ls out. It's here. So the right way to do this would be to change this and see ls error. So here we will have one file for output and one file for error. So what if we want to redirect, for example, at the same time a command, the error and the output in two different files without having to run the command twice as we did here? To illustrate this, let's see, for example, here, again, our root evil system administrator created a folder inside our home folder called only for root. So we cannot access this folder. If I go here and select ls only for root, it's going to tell me that I don't have permissions because it is owned by root, and others is basically no permissions at all of any kind. So to illustrate a little bit how this works, let's create a folder here, make dir documents, for example. So now inside documents, let's create an empty file. If we come back to our own folder again, we see the directory is there. So if we type the command ls l r, what it's going to do is to go recursively. Basically, it's going to go to every single directory that it finds, and it's going to list the contents. So if we execute this, we see that it's first showing the contents of here, the home folder. Then it's getting into the documents folder that we created, and it's showing us what it's inside, the hello.txt. And then it tries to get into the only for root, but there is a permission denied. So first, let's run this again, but we are just normally redirect this to ls out, and let's see what happens. We see we get the error that we couldn't get into the only for root folder, and if we cat the content of ls out, we will get whatever was supposed to go to the out. It means the normal standard output. So we have the current folder and the documents, the ones it was able to get in. If we run the same command, but in this case put a 2 here, and let's change this to R, then we will have the same output that was supposed to go to the standard output, but we'll not see the error because the error is now in ls air.txt. And so the directory not found. So how can we do this in only one go? Basically, we execute the command ls lr, the same as before. Then we redirect, as usual, ls out. And then we do an error redirection to ls air. So if we run this, no output in the screen. But if we cat the content of each file, we have ls out with a normal output destined for standard output. And then if we cat ls air, we have the error there. So this is a way to actually keep in two different separated files errors and normal like succeed output. What if we now want to have the normal output and the error, all of them in one single file? So in this case, ls lr, let's call this ls all.txt. And this is gonna just do the normal output. Well, here's where a little bit of the magic works. We are telling take the error descriptor and redirect it to descriptor 1, which is the standard output. So what is happening here is like, this is the command, it's going to generate an output. Here is telling to redirect the output, the standard output, to this file. And then here is telling redirect the standard error into the standard output, which is going to be redirected to this file. So now if we run this, we see that there is a file here called lsall. So cat lsall, we see the same message that we will see normally on the screen. We have here our output and then the error when it happens. So this is a little bit more of a clear, similar representation of what we would get in the screen. Okay, now let's see how to redirect the input. The input so far has been coming from the keyboard, but we can also redirect that input from a file into a program. So it's going to pick up the content of that file, thinking that it's coming from the same as if it was coming from the keyboard. Before we do that, there is a command called sort, which helps sorting the contents of a file from the standard input. For example, if we just type sort by itself and press enter, we can have here type everything we want, A, C, G, Z, hello, X, anything. And then if we type Control D, which is a special control character known as the end of transmission in Unicode, there is basically an end of file. If we type Control D, then it's going to exit the program basically, but before that it's going to return the sorting that is doing. So as you can see here, A, C, G, Z, hello, it sorted it in alphabetical order. So that's what the sort command does. It sorts stuff basically. For this example, I have prepared here a file called countries.txt. We cat the contents of this. It's basically a bunch of countries in Europe, and they are not ordered by any order, just are randomly listed here. So we want to input the content of that file countries into sort, so we can have a list of sorted countries. So we type sort, and then before we were using this character for the redirection, getting the output of our program into a file, but this time we're going to use the reverse one. So in this case, we pass the file countries, which have all the list of countries, into sort. So it's going to take all that content and pass it to sort as an input from this, like if it was from the standard input. We press enter, and you can see that sort now sorted everything, all alphabetically. In this way, these two characters here are basically redirections, either from an origin from a program into a file, or the other way around, from a file into a program, by using the streams, data streams, the standard data streams that we saw before. Finally, let's see how to get the output from one program and pass it to the input of another one. For that, we use something called pipes, and the character for that is this one, this vertical line, which looks like a pipe. Before we get into this, let's learn about a couple of commands. One of them is echo. Echo is like a print, basically, command. What it does, you can pass anything here, hello world, and it's going to print it on the screen. The other utility is called TR translate. It does a lot of operations, like for example, removing repeated characters, converting uppercase to lowercase, or replacing a character by another one. So an easy way to see how it works, for example, echo, and I have here hello world, and I pipe. Basically what it does is taking the output, which is hello world, and it's gonna pipe it through TR. So this pipe here is connecting these two programs, basically is connecting the output of these, which is hello world, into the input for TR. So here in TR, I'm going to say I want to replace every O by an X. So you can see hello helks works or something. So basically it's replacing that with X. Every O that it finds, it replaces it with an X. For example, if we cat the content of countries, the previous file, and we pipe it through TR, and we say change every A, for example, by a capital X. Enter. As you can see, all these countries have been replaced. The lowercase a, not in this case, the uppercase, the lowercase a has been replaced by a capital uppercase X. We can also change to uppercase, for example, echo uppercase, and we pass it to TR, and here we can pass sets of characters. So I said the sets of all characters that which are lowercase a to Z. Well, I want it to be replaced by the equivalent in uppercase, and is uppercase here. We can also do a little bit more creative things. For example, ls, l, and the root of the file system. We have here a lot of numbers. So in this case, let's do ls and pipe it through tr, and we pass and tell, okay, every number from 0 to 9, I want it to be converted into a capital X. And you can see the output is just replacing that on the fly, on the go. So we can just also, for example, do something a little bit more than that and say, okay, take all of these and redirect these to ls out. And then we have here ls out, we have that output which was converted into a file. So you can see here we can really play with all of these as much as we want. We can pipe things, like this program creates an output, we pipe it through as the input for this one creates an output, we redirect that output into a file. So the possibilities are endless. Basically, you can combine this in many ways. Next, we're going to talk about environment variables. Environment variables are useful for many reasons. Programs use them to change their behavior and the shells use them for configuration purposes and so on. They are extremely useful, and we will see more about them in future videos. To see the environment variables that are currently in our session here in the shell, we can use the command called env from environment. And see here, you can see a lot of data. Many of these things probably don't make sense now to us, but for example, here is saying like, okay, this is the default for the mail program. This is the path where to find the different programs that we execute, where in the file system to find these files is the content of the variable path, the user, which is the user we are in, and so forth. You can set an environment variable as local or global. This is a local definition. My var equal to subscribe to messy circuits. Now, if we want to see the content of this var, we have to reference it by placing a $sign in front of it. So echo my var, and it's going to print the content of that variable that we just set. A local variable means that it is only defined within the shell we are working in this very moment. It is not available in any other subshell or program invoked by the current shell. To make it global, we use the export command. So export my var. Now, if we query is going to give us the updated value, but the difference is that if now we start, for example, script, is going to see the value of this variable. Okay, now I think we have enough knowledge to start learning about bash scripting. This is a very, very wide topic that we cannot cover in this video. I'm going to make another video specific for bash development. So what is a shell script? Basically, every command that we were typing into the command line before, we put them all together into one text file, because it is a text file. We can edit it with any text editor, and the shell is going to execute those commands one after another. So we don't have to repeat those commands again and again. We can just pack them into a text file and then tell the shell to run it. Well, this is basically a program, because the shell is a lot more complex than those simple commands that we saw. So we basically can have like a program. We can program it to do a lot of tasks on the system. In order to properly start a shell script, we need to place these at the beginning. This symbol here is called shebang, and it comes from shell and something that's a bit not known exactly the origin, but it's called shebang. And it's basically a symbol to tell the shell that whatever is coming after is the path to find the program. In this case, it's going to be bash, that is going to execute this script. So what it's going to do is going to ignore this first line, and is going to pass the current path of this script that we are creating as the first parameter to the program, the bash, the shell that we indicate here. So in this case, it's bash. It could be something else. It could be a Python script. It could be ZSH, which is another shell. Basically, we're telling, go to this path in this place here where you have that program called bash, and take this file path, the location where this file is located, and pass it to it directly as the first parameter. Then after that, in the following lines, you continue and you start programming your shell script, which will have a lot of variable declarations and functions and all sorts of things. Okay, maybe an example is going to make all of these easier. So we don't have any files here. Let's create one. Nano, and let's call it hello.sh. The extension is not important. You don't really need it to create a shell script, but I really recommend, because it's easy and good for other people that may see your code and say, okay, this file is a shell script by just looking at the name. So here in Nano, we can start by placing the shebang, and then we are just going to execute it, put the same command that we were doing before, for example, echo hello world. So here we basically to exit with the Control X, and it's going to ask save modify buffer, and it say letter Y to say yes, and then enter to is going to write to hello.sh. Okay, here we have our file. So one way to execute this, we just don't need to do anything. We just type bash and pass hello sh. So it's going to print hello world, because what it's going to do internally is going to execute this line of code that we wrote in there. Now, we don't always have to do this bash and pass the name of the script. Actually, it's not really recommended, because maybe the developer wanted to run this on a particular shell or with certain parameters. So the right way to do this is to change the permissions of this file to execute. So for the time being, I want to change the execute permissions of this just for the user. I don't want other people to execute this program. So hello. And now if we see here, we can see that the X has been added. So now we can execute this program. In order to do that, we have to type dot and then slash and hello. If we do that and press enter, now it's executed. For example, let's get back and say change mode and say user and remove the execution of hello.sh. We can see that it is the same as it was before. Now, if I try to do the same, hello sh, it's going to give me an error, permission denied, as we saw at the beginning of the video. So this basically explains how that actually works. The execute permission works. Now, if we try to execute it again, boom, it's going to work. So we didn't need to pass the bash option here because it's already included inside the shebang. It's telling where to find that program that is going to run this script, basically. Let's make this a little bit more interesting. And we can do like sleep 3 and then echo, how are you doing? And then sleep 3, bye. It's a very simple conversation, for example. So save to buffer, yes. And now if we execute this, it's gonna, hello world, wait for 3 seconds, next line, how are you doing? Wait for 3 seconds and then bye. Basically here what happens is just executing sequentially every single line of the script. Now let's say that, for example, we want to say hello, the name of someone. There are certain variables that we can use inside a bash script. One of them is the parameters we can pass to that script. So for example, if we query the variable $0, that dollar, remember, is a way to reference a variable, as when we created the variable before, my var, remember that? Well, that way to make a reference to extract the value of that is with a dollar symbol. So now if we save this and we execute hello, it's gonna show hello.sh. And the reason is because for every script that we execute, by default, the first parameter is the location of the script itself. And by parameter, I mean, for example, here in ls, -l is a parameter. When we did change mode and then user plus x and blah, 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 everything we did here, those are all parameters as well, what we pass to it. So the same, our script is able to receive parameters, and the first parameter that is passed by default is the path, the location of the script itself. So now, for example, if I say hello and I say Joe, it's not going to show anything because the first parameter it was passed, but the script internally is not processing that parameter. Let's do that now, something different here, and say like echo hello $1. And 1 is the first parameter, basically the second, because the first is the script itself. So $1 is the second parameter passed to the script. So if we execute this, we have hello, nothing, because we didn't pass anything. But if we say Joe, it's going to say hello, Joe. If we say hello, Pete, it's going to say hello, Pete. So basically anything we pass as that parameter is going to be executed. It's going to be read from that variable. So let's do one more thing. For example, there is a command called seek from sequence, and say 110 is going to print a sequence of numbers from 1 to 10. Okay, that's interesting. But now, for example, how can I pass the output of this program into echo? Okay, well, there is something else we can do here, and say like echo $ parentheses seek 110 and close the parentheses. And now we have the same output of seek here printed by echo. What it's doing is basically executing this inside this construct here and is replacing this by that output. So Echo is going to process it in this way. It's going to show us that output there. Okay, how can we use this, for example, to print hello world several times? If I want to say print hello world 10 times. So for example, here we can say like, okay, I want to get the first parameter, which is $1, and I want to run it, use it as a way to run how many times I want to print hello world. So there is a construct called for, which is to create loops. So I say for example, a variable I, we are not going to use it, in sequence 110 to echo hello world done. Now if we execute hello world, it's going to print hello world 10 times. But if I want to tell the program how many times I want it to be printed, so nano hello world, and let's replace this 10 here by the variable $1. This sounds a little bit advanced. I'm kind of running a little bit, but it's to give you just an idea of what bash scripting would look like. But we're going to create a video where we're going to do all of these from zero, from scratch, so you become a ninja of the bash scripting. So save this. Now, if I execute this as it is, it's going to give me an error because we didn't pass a parameter to the variable. But if I do again and say, like, for example, 5, it's going to print hello world 5 times. If I do it 1, it's going to print 1. If I do it 100, it's going to print it 100 times here. So this is a way to show how basically a bash script is structured. So remember, here you have the shebang, then where you want what kind of shell is going to run this script. There are more parameters you can pass here. Of course, all of these can get extremely complex, but it's also extremely simple for doing simple tasks to understand the basics. Here we have a loop, we're passing a variable, we are basically execute something inside that loop. All of this will be clear in another video about bash, but I want you to understand that here we're basically editing a text file and we can pass any commands that we want. We can create scripts which call other scripts, which has functions, which connect to the internet, download something, modify something. They are extremely powerful. Finally, remember when we were talking about that of the chmod, and we can pass here, for example, numbers to change the permissions of files. Well, that's the Octal system where we were talking before about doing it. So let's see how that works. So there are different numerical base systems. So I have a video explaining how the binary and hexadecimal work. And it's a pretty old video and it's explaining that on how to use it on a retro computer, on a Commodore 64, but it doesn't matter because the basics are the same. So binary system is based on 2 symbols, 0 and 1, in 2 symbols to represent all the numbers. And the decimal system that we have used, well, 10 from 0 to 9. The number 10, in fact, is not really a symbol, it's a combination of the symbol 1 and the symbol 0. We could use anything we want, any kind of representation for the number. And then from there, we can count as much as we want, like any other system. So there is one called Octal. Octal from 8 and is from 0 to 7. We can count in binary from 0 to 7, but as you can see here, at the same time, these 3 zeros and the file mode that we had before, we can see a correlation here. We have 3 zeros and 3 hyphens here. So you can see the one works like a switch on and off. So if we go to the next one, we have 1 here. It's going to be X there because that's the position for the execute permission. Then a 1 here is going to become the W on the other side. That's the position for writing. This one is writing and execute, but not reading. And it'll be a weird situation, but you can do it. The other one is going to be 1 here and reading there, only reading. 101 would be reading, nothing, and execute, which is something you might want because you want someone to execute a file, see what is inside, but you don't want them to be able to modify it. Here is a common one, 11 RW, and then the final one, all the switches on, is going to be all the permissions on. So basically, this is what you have, these numbers here, which some of them are more common for the most common operations that we use, but they have a direct representation in binary, which actually works like a switch board to the file mode that you have in the permissions. And that's basically how these numbers work. So here, for example, remembering that table that I showed before, go back in the video, pause it, write it down, because you're going to see it many times in configurations and everywhere. So I really recommend for you to memorize at least the scenarios which are more common. So you will understand what it means when people say like change mode, and I'm going to say, okay, I want this file now to be, for example, read and write for the user, read only for the group, and nothing for everybody else. And I say hello world, ls, and boom, I have it there. So in order to easily understand this, really write that down, put in a post-it somewhere so you can see it frequently and memorize it. Well, this wraps it up for now. I hope you have fun and learned something new. Remember to subscribe, and as always, thanks for watching and see you in the next video.